Hello, in this video we will compare the LINEST and the LOGEST function. So here we have a data set in the exponential form where the value of y increases exponentially. So we have an equation for y which is b0 times exponent x times ln b1. We can convert the LOGEST function. We can get the LOGEST function of this data set range. We have data y and data x and show the full statistics. There are 10 outputs. We can also use the LINEST, but we have to convert the, the equation to its linear form or transform it in linear form. To transform, we use ln y equals ln b0 plus, this time it's x ln b1 because the logarithm of exponent is the value itself. So we can factor out ln b0 and ln b1 in a different matrix. That leaves 1 plus x or 1 comma x. So this is the ln b, b0 and ln b1 matrix. So we begin with the ln y. Our formula, ln of the y values. Next, we complete the 1 comma x matrix. We have the 1 column and the x column. Our formula of the x values. Now that we have the ln values, we can now calculate or derive the LINEST outputs. So you have LINEST, we have the data y this time, and our data x will be the same, and we enter the full statistics. You will notice the values, the standard errors of the coefficients are the same. The values for r squared, they're all the same. The value for standard error value or stay x, standard error of the estimate, they're the same. The degrees of freedom, they're the same. The residual sum of square, also they're the same values. We have the same output for the regression sum of square and f statistics. But we have different values of the coefficient. Here the coefficient is the logarithm of this coefficient. So the logarithm of this coefficient, so the logarithm of 1.23 equals 0.211, and the logarithm of 5.42 is 1.69. We can also use the r square, the built-in r square function. Because it's linear, we can now r square function of ln y and the x values, which match to the LINEST output RSQ and the LOGEST output RSQ. We can also calculate the stay x or standard error estimate of ln y and the x values. These also match our LINEST output and the LOGEST output. They're the same. We calculate the rows, the population, which is the rows of the data set. That's 9. And we can calculate the degrees of freedom, which is rows minus columns of the dataset range. 7. Also match to our LINEST output and LOGEST output. Next, we calculate the Jarina inverse so that we can continue calculating for the coefficients. We start with the Jarina inverse, which is minverse and mult transpose of this matrix and itself. And we can calculate the Jarina cofactor, which is m mult transpose of this matrix and the y values, the L and y values. Now we can calculate for the coefficients. The coefficient will be m multi of the P-Jarina inverse and the P-Jarina cofactor. Now that we have the cofactor, so this ln b0 matches to the output ln b0 of the LINEST, and ln b1 matches to the ln b1 of the LINEST. We can also calculate for the exponent or the value of b0 using exponent, and it's 5.42 matches to b0 of the logest, and is equal to exponent, that's 1.2349 matches to the b1 of the logest function. Now we can calculate for the estimated ln y hat, which is equal to m multi of this matrix and the coefficients. Now that we have the ln y hat or coefficient, we got the ln estimate, we can now calculate for the residual sum of square. The formula for that is sum x m y 2, the sum of squares of the differences of ln y and ln y hat. So 0.02927799 to match with our RSS of the LINEST function and the logest function. We can also use DFD stay x squared formula, which is equal to DFD, degrees of freedom denominator, times stay x squared to the power 2. Stay x to the power 2 or stay x squared. Again, we have the same value, 0.02927799 matches to our calculation of sum x my2, RSS of the LINEST output, and RSS of the logest output. Now we can calculate for the regression sum of square, which is equal to RSQ times the population times the variance of the population ln y. The variance of the population ln y. That's 2.135 matches to our ESS or regression sum of squares in the LINEST output and the logest output. Now we can calculate for the F statistics, which is ESS divided by 1. That's because there's only one independent variable. Divided by stay x squared, which is stay x to the power 2. 510.474 matches to the F statistics in the LINEST output and F statistic in the logest output. Now we can calculate for the standard error estimate, which is equal to standard error value of B0 is equal to stay x times square root of P Jarina red. And the standard error value of B1, coefficient B1, is equal to stay x times square root of P Jarina blue. This value matches to our LINEST output and the logest output. They are the same. This completes the comparison of the logest and the